So this is the cost minimization problem that we solved earlier. Now we're going to go ahead and write it on Excel and try to solve the same problem using the solver functionality of Excel. And here we go. So I'm going to create a couple of different columns representing capital, which we decided to machines, basically machine hours, labor, worker hours, L. I think we decided to go with the letter variable L. Output, which in our function that is represented by Q. And finally, let's go ahead and write it as the cost of, say, capital, the overall cost of labor, and finally the total cost. Perfect. All right, so well, for this portion it is just basically R, the rental rate of capital, times K. Oops. Okay, so maybe I should just go ahead and write it like this. R times, when you put that apostrophe, it is just telling you that it is a text. All right, so W times L, and finally this is the overall cost because of the capital input and the labor input, right, which is the overall, everything included. So it is just going to be looking like this. It's going to be R times K plus W times L. So that's the function we're trying to optimize. All right, so let's have a look at a couple of examples which will produce 1,000 units. One thing which is interesting is 1,000, when you set it equal to 10 times the square root of K times L, because you want to make that left hand side is 1,000 and the right hand side is 10 times the square root, an expression there. So that square root thing must be 100, which 100 times 10 will give you 1,000. And what is the number whose square root is at 100 is 10,000, right? So any combination of K and L whose product is 10,000 should give me the desired output, right? So the output here is just the product of this times that thing. All right, so for this one, and as a result, for instance, as an example, if capital is, say, 10,000, then labor 1, their product is that's wrong. Output is just not their product. It is 10 times the square root of their product. Okay, there we go. 10 times the square root of their product, namely this times this, and close the parentheses. Does that make sense? So, and indeed it is 1,000 units. So as another combination which would probably work will be, what if I combine 5,000 hours of capital with 2 hours of labor? The product is 10,000. The square root of 10,000 is 100. 100 times 10 is, so therefore this output function, I can drag it down, and any comment, yes, it gives you the desired 1,000. Another way to get 1,000 for 10,000 for their products is something like, for instance, 2,504. Any of these combinations are good combinations, but the question is which one is the best alternative, the cheapest alternative, right? That's here's another example. Probably I'm trying to find out the easier, like the even cases. 5 here, that gives you 1,000. How about 1,000 combined with 10? That gives you 1,000 units of output, and so on, right? So maybe 520, and why not 250 and 40? A combination of 250 hours of capital, machines, and 40 hours of labor gives 1,000 units of output. All of these are good alternatives. The question is which one is the cheapest one, right? 250 would do, right? Or let me just answer 100 and 100, and then we can go the other way around. So 50 and 200, because it's symmetric with respect to capital and labor, the reverse will also work. So 40 and 250, and what's the next one? 40 and 20 and 50. It automatically, even though there's no formula, Excel understands what I'm doing, so it automatically generates the formula for me. 10 and 1,000. The next one would be 5 and, or anything in between them, right? So I'm creating a lot of alternatives to see which one is the one which will minimize the total cost, right? So I have so many alternatives in front of me. I don't know which alternative to choose, right? You are the manager. Wait, why did this one come out wrong? Oh, for 500 here, sorry. This one should have been 500. There we go. Okay, so I have alternatives in front of me, and I want to see which alternative will minimize the cost. Well, let's just quickly calculate the cost. The cost here is the cost of the capital of the machines is just 9 times the machine hours that we rented it for, and that's pretty much it. And this is 16 times the labor hours that we are using, and as a result the total of these two numbers is what it is, $90,016. In fact, let me just go ahead and put dollar signs over here. There you go. Well, I don't want to see the cents, it's too much. Okay, there you go. So $90,016 if I were to use this very first alternative, right? I can go ahead and shift this by 1. So let me write alternative number, alternative. So we have different alternatives in front of us, and we want to see which one is the cheapest alternative. So alternative number, there you go. Okay, alternative 1, 2, 3, 4, 5, 6, 7. Oops. Actually, I don't even need to do it, right? I can just go ahead and drag it. I have 17 alternatives in front of me, and let's see which one minimizes the cost. And I'm not even sure if that's the answer, right? Because the answer can be somewhere in between any two alternatives, right? So, but for the time being, all I will do is just drag this formula down by left clicking it and then taking it all the way down. Oops, the bottom number doesn't show up. Okay, 100. Okay, so among all these different alternatives, it seems the one with the least cost is this one, alternative 9. Oops, sorry for that. Alternative 9 is the cheapest option, where I use an equal amount of capital and labor. 100 hours of capital and 100 hours of labor combined gives me 1,000 output units, and the overall cost of the machines is $900. The overall cost of labor is $1,600, and that gives me a total cost of $2,500. Now, am I satisfied with this? I'm not quite. I want to see if I can go further than that. Well, how? Well, maybe a combination in between them. So for instance, what if I were to use a little bit more capital and a little bit less labor, right? So something like this. Let me insert something here. Let's see what I can do. So this is a case between 8 and 9. 8, 9. So somewhere between 8 and 9. All right, so let's check. How about 125 units of capital combined with, okay, how many units of labor should I combine it with so that I have exactly 10,000 as a product? I think it is 80, right? There you go. Whoa, look at that. That's even cheaper than this option. So let me just forget about that highlight, right? So remove the highlight. Instead, I want to highlight this one. So this one so far is the best. But is this the answer? Well, if you remember our solution earlier by paper pencil, we found out that the cheapest option was $2,400, right? Not $2,405. There's yet a better way to do that. But so far, we have this as the best combination, 125 units of capital combined with, or hours of capital combined with 80 hours of labor. I can produce my objective, which is 1,000 units, right? So remember, that's the thing. I want to be able to produce 1,000 units, and this is so far the cheapest one. But let's see if Excel can give us a better option. So what I will do is I will here write the code. Well, when I say code, really the application, that I will use the function right here. So let me just go ahead and now think about what I'm going to do. First of all, the formula is still correct. I want to just make sure the formula is there. It is 9 times whatever is here, the capital. And this one is 16 times whatever here, labor, right? And the total cost will be just the sum of the part attributed to the capital plus the part attributed to labor. There you go. So this is the cost part, and obviously the total cost is what I care for. All right, so there we go. Now I should be careful. I want the output to remain exactly at 1000 by changing capital and labor. And it turns out that we just observed it earlier. As long as capital and labor, they multiply out to 10,000, because square root of 10,000 is 100. 100 times 10 is 1,000. It works out beautifully. So that gives me an idea. Whatever is capital, I will set labor to be capital divided by 10,000 divided by that capital amount. So this number here is whatever is the so that number is 10,000 divided by whatever the capital. So now check out, obviously right now it is 0, so maybe I should just plug in a number here, let's say 3 for instance, right? So at least it shows up a number. It's not the optimal way, right? The total cost 53,000, we can do way better than that. That's definitely not, I don't want to rent 3,333 hours of labor and only 3 hours of capital. I want to use much more capital than labor, because at least much more than this, because capital is cheaper. We decided on that. But the good news is, let's see if their product now will give me the 10,000. Yes, it gives the 10,000. So therefore, let's write out the output. Output is 10 times the square root. Let me just, basically, I'm just rewriting the same formula. This times that, labor, and sure enough, it is 1. Okay, perfect. So far, everything is perfect. Now I have, instead of keep writing 2 of them at the same time, all I do is, if I change this, it automatically tells me what labor should be. And in fact, I can do trial and error now. I can do trial and error, trying to reduce this as much as I can. For instance, earlier we tried 125. 125 gives us 2405. Let's see if I can do better. How about 126? Hey, 126 is even better. How about 127? That 127 is even better. 128, even better. 120, it keeps reducing the cost, right? I think I should keep going. How about 130? Oh, wow, it seems it's not changing. So let me just go ahead and add 2 more decimal places of accuracy, because it's not clear if there's any change or whatsoever. Let's go back to 129. 129 was 2401.31 cents. And when I tried 130, it is, oh, it's definitely cheaper. So I need to keep going. How about 131? It's even cheaper, 40 cents cheaper, but regardless, it's cheaper. 132. Hey, that's even cheaper. 133. Hey, that's really good. How about 134? Uh-oh, 134 started increasing. So the answer should be somewhere between 133 and 134 units of capital. I know the exact answer, right? The exact answer is 400 over 3, which is 133.33, right? I know the true answer is this. It's like an infinite. Yes, that explains. Okay, how does Excel do it? Well, it's very easy for Excel to do it. Let me just write a random number here. Let's say 12, for instance. Okay, there you go. Or maybe 20, so that I can see the cost a number here. Otherwise, it's not showing me any number. Okay, there you go. Okay, let's say 15, for instance. All right, good. So what we will do is, it's a very simple idea. I just select the cell. I don't even have to select, to be honest. But okay, so we go to data. We go to solver. If you don't see solver here on your machines, the way to include it is go to file and go to either options. You can see it at the bottom. In my case, I can't see it, so I need to click more, and then I can see options. All right, click on options, and under options, you will see add-ins, and under add-ins, you will see these buttons. Make sure you select Excel add-ins, and then you press go. And then make sure solver add-in is checked here. Usually I have these other 3 checked all the time, but it will make your machine work slightly slower. Like Excel will work a little bit slower. So in other times when you don't need these functions, you can just uncheck them. So the machine will work, Excel will work faster. But in this case, we need solver. Okay, now it's time to let the Excel take over from here. You just press solver. Solver basically is an optimization. It's an optimization thing. So let's. I think you guys cannot exactly see my whole screen, right? That's shame. At the bottom, all that it says is solve. Basically, there's nothing at the bottom. Okay, let me first show the top page. So we want to optimize. Okay, so what is it that we're trying to optimize? The content of G8. We want to minimize it, right? So we select the content of G8. Or either you can select that press what you want to optimize, which is already there, and then check it again. Okay, we now know it. Instead of maximization, it's a minimization. We want to minimize the cost, not maximize it, by changing which cell? By changing capital, right? Because labor, there's a formula underneath this. So I want to keep changing this number over here. All right. And finally, what are my constraints? I already have the constraint here. I did that smart observation. Replace the L with 10,000 divided by K. I don't need a further constraint, but that's if I didn't handled it there, I should have put it right here. I should have added a constraint here. But because I already handled, I don't want to add another constraint. Nothing is needed. Make unconstrained variables non-negative. Yes, that's definitely true because K and L are positive all the time. Perfect. And that's pretty much it. As soon as I press solve at the bottom, I should be good. So here you can see different algorithms. The one that we will use is the non-linear optimization. All right, just press solve now at the bottom. You guys can't see it at the moment. I just press solve and that's it. Oh my gosh, look at that. That's exactly the solution we were seeking, right? Do you guys see that? That's amazing. So that gave us the optimal combination of capital and labor, so as to produce 1,000 units of output and such that the cost is minimum $2,400 cost. So optimization is automatically completed by Excel in that case. It's very good. Now what I want to do is I want to go one step further than that. So remember how earlier we are told that the rental rate of capital is 9 and the wage rate is 16, right? So maybe, so rental rate of machines is $9 and wage rate is 6. Why don't I refer the formulas here to those cells automatically, right? So let's just go ahead and do that. So it will only impact these three columns, E, F, and G, but it will give us a lot of flexibility. So check this out. So replace the 9 there with that 9 over there and press enter, and finally replace this 16 over here with this 16 over here, and I'll pretty much do the same for the other things that we just did. It seems from the outside that nothing is changing, right? So why are we even doing this? No number is changing whatsoever. It's the same thing. But it turns out it's good programming. It's good modeling, I should say. So scroll all the way down. There you go. All right. I messed up. Okay. Oh, sorry. I forgot to mention the difference between relative reference and absolute reference. I should have done an absolute reference here. So here it's not really I1. I should have pressed F4. Oops, function F4. All right. So make sure you put $ next to that I, right? So either in your machine it should be F4 or function F4. Try it. If it's not doing it properly, just put $ the way I'm doing right here. And then press enter. And we should have done the same thing here as well. Let's just go ahead. Let me just type the $ actually. It's easier to type them, I guess. There you go. And now I should drag the formulas. All right, so let's just go ahead and drag it by left click and dragging. There you go. So again, it seems so far the optimal allocation is this, but later on when we did use solver, it realized that we can do even better than that. Combining 133 units of capital with 75. So this is the cost minimizing alternative. Minimum. This is the best alternative, not the yellow one, right? This was the second best probably or something like that. All right, so 2,400 is the least. So why did I even bother doing that, referring to these cells? Why? Well, the thing is, now I can keep updating the solution. Suppose that, what if rental rate of machines and the labor hours, the rate of labor hours keeps changing. I want to see what will be my overall cost, how it will change if there's hypothetically a change in those costs. In fact, what I can do is I can even construct a table. So this will be a minimum cost table, depending on what is the values for R and W. So for instance, R can be fluctuating between 7, 8, 9, 10, or 11. So where in this case R is 9, right? So this column belongs to R. Let me just move it slightly to the right. Okay, there we go. So this is the column for R, and the column for W, the row, the numbers that I'm going to write will be now related to W. What if W is fluctuating between 12, 14, 16, 18 and 20. We are never sure which one can it be. So what we can do is, regardless, we can solve the problem, right? Each of these scenarios. So this is kind of a scenario analysis here. So technically there's a way on Excel to do it. It's called the data tables. Let me go ahead and show them to you guys. It is under data tools, no, forecast. Oh yeah, what if analysis. And it is these data tables. That's how we do it officially. But I won't bother going into that right now. During the 6th week, we will look into those things in more detail. But at the moment, what I can do is the following. I can go ahead and change these numbers. If R were to be 7 and W were to be 12, this no longer would have been the optimal allocation. Let's see what would have been the optimal allocation then. I will simply go to the data ribbon again, solver. Everything else is unchanged. So all I do is just solve the new problem, right? The new problem is, again, the cost function now, the combination has changed, right? So check this out. If I press OK now, let's see what happens. Solve. Okay. Oh, so this is the minimum cost. And now the new combination is slightly different. Why is it that the optimal combination previously it was 133 units of capital and 75 units of labor, and now it seems we are cutting on the capital and adding more labor into the system. We still produce 1000 units of output, which is the amount of contracts that we want to our promises that we want to deliver to our customers, right? But why is it that we consume we end up using less capital in our production process and more labor compared to what it was previously? And it turns out that comparing it to the previous prices, which were $9 was the rental rate of capital and $16 was the rental rate of wages, it seems both of them are now cheaper compared to what it was. But it turns out that wage got 25% cheaper versus capital got only a little bit more than 20% cheaper. So in a sense, wage got more cheaper than rental rate of capital. Do you guys see that? Both of them got cheaper, but wage got more cheap compared to rent. Regardless, both of the inputs are cheaper. That's why the overall cost is way lower than what it was previously. So under these circumstances, you can produce everything at this cost. Let me just write it up to integer. So we know the scenario right here. This one is $2,400, right? But depending on what state of the economy will be over the next quarter or period, right? So let me put a $sign here, and I don't need this. Okay, there you go. We can create this hypothetical table as well. So we know for sure, depending on all these uncertainties in the future, I know how to I still produce 1000 units, namely here 1000 units, though with different combinations of capital and labor. And all these future uncertainties, I can put them into this matrix. I know that if things go really good, both rental rate of machines and labor hours are cheaper, both of them, $7 and $12 respectively, then the whole production process will be as cheap as $1,800. Or if both of them were to get super expensive, let's just quickly check that, $11 for this one and $20 for that one. Let's see what would be the optimal combination. So go to data ribbon again, we go to solver, pretty much everything is the same, nothing changes, press solve. And okay, wow, so now the production process is 2966 significant, but this is the worst thing that can happen according to your judgments. You don't feel like wages will go past beyond $20, or there will be a shortage of machines or funds, money, where it will be significantly more expensive to rent machines. So $11 for that and 20. So this is the worst thing that can happen. This is the best thing that can happen, and most likely we will end up in somewhere here or any other combination. I will leave it to you to complete this. For instance, in this case it will be 11 and 14, right? So this one will be 14, and then you just press solver one more time. So just as a record, let's just do it one more time. Solver, everything else is the same because it's preset. Just say solve and that's it. Because it's so easy, let me just write it here. So if capital were 11 and labor was 14, so the outcome comes out as 2481, slightly more expensive than what currently is. But data tables is a great tool to just finish this in one click, and you guys already saw where that click is. An alternative is to write a code on Excel. Excel is supported by Visual Basic, VBA, and it's really nice application that you guys can also utilize if you want to, and I'll leave it to you guys again to have a look at that for yourself. And that's it. So we are able to solve the problem in the optimal case, which was, I think in our case, rental rate of machines was $9, wage rate was $16. Based on those, the optimal allocation came out. Let me just solve it one more time. We just plugged in this, make sure this is checked min, this is, and then there's a check mark here, and then you press solve. Yes, it came out as 2400, just like the way when we solved it on paper pencil. Hope you enjoyed it, and looking forward to see you guys in our next lecture.